1. Task introduction. In an automotive welding production line, how can an industrial robot dynamically switch its operation program through external signals to adapt to different vehicle models? In this lesson, we will examine the core mechanism of PNS program number selection control, where binary signal combinations are used to select program numbers, enabling flexible scheduling of robots in multitask production scenarios. 2. Learning objectives. 1. Explain the working principle of PNS control and its signal mapping rules. 2. Configure robot PNS function parameters, base number, signal pulse width. 3. Operate the 3-layer signal interaction process: input layer, processing layer, output layer. 4. Troubleshoot common causes of program start failure. 3. Guiding questions. 1. With an 8-bit binary signal, G4.0 to G4.7, how many program numbers can be supported at most? 2. How is the target program name PNS113 generated? 3. What are the timing requirements for triggering signals G5.0 and G5.1? 4. Why is the program name PNS013 invalid? 4. Principles and applications of PNS. In modern industrial production, robots are no longer merely mechanical devices performing fixed tasks. They have evolved into flexible, programmable, intelligent execution units, widely deployed across multitask, multi-station, and multi-product automated production lines. To enable robots to flexibly execute different tasks according to varying production requirements, control systems typically adopt a program selection approach to schedule and assign commands to robots. This section introduces a commonly used control mechanism, PNS, to help you understand how industrial robots select and execute preset programs through external signals. PNS control is a method that allows robots to choose internal task programs based on external input signals. These signals usually come from the production line's control system, such as a programmable logic controller, PLC, host computer, push-button switches, or sensors. By configuring specific combinations of input signal states, the system can instruct the robot to execute the program corresponding to a designated number, enabling it to perform tasks such as transport, assembly, inspection, or palletizing. This method is particularly well suited for flexible manufacturing environments where task types are numerous and processes change frequently. The core idea of PNS control is to combine multiple binary input signals to represent an integer number, with each number corresponding to a specific robot program. When the robot receives a valid start signal, it selects the task program that matches the number from its internal program list and executes it immediately. For example, if 3 input signals are defined, they can be combined into 8 possible states from 000 to 111, corresponding to 8 different program numbers. These numbers are mapped one-to-one with program names in the robot's control system. Take a typical production line as an example. At a certain robot workstation, the robot needs to perform different gripping or assembly actions depending on the type of workpiece. When a workpiece arrives at the designated position, the upstream control system issues a signal. Input signal 001 indicates task 1, execute program 1. Input signal 010 indicates task 2, execute program 2. Input signal 011 indicates task 3, execute program 3, and so forth. The robot control system determines which task to execute by reading the combination of input signal states. Once it receives the start signal, it initiates the corresponding program. In industrial practice, PNS control offers the following advantages: operational flexibility. robots can automatically select tasks through external signal control, eliminating the need for manual program selection. High system integration easily integrates with PLCs, sensors, HMIs, and other devices to achieve complete automation logic. Strong scalability. Increasing the number of input signals allows support for a greater range of program numbers. Adaptability to changing production demands. Well suited for production scenarios with diverse products and frequent task switching. To implement PNS control in a robot system, the following configurations are typically required. Define program numbers and corresponding tasks. Map each program number to a specific task process. For example, Program 1 for pick work piece A, Program 2 for assemble part B. Set up signal input interfaces. Map external input signals to the robot control system's program selection signals. Configure the program selection mode. In the robot control system, set the current selection method to number selection, PNS mode. Establish start conditions. Configure the start signal to ensure that the robot automatically executes the selected program when the signal is valid and the robot is in standby mode. The basic steps to master PNS control are as follows. Write multiple task programs, each performing a typical operation. For example, transport, positioning, or homing. Define virtual signal input conditions using switch simulations, software buttons, or PLC simulation signals. Configure the correspondence between program numbers and input signals. Set up start conditions and verify whether the robot correctly selects and executes the corresponding task based on different signals. Test responses to multiple signal switches in actual operation and observe whether program selection and execution are accurate and reliable. 5. PNS Program Start Task. PNS is an external program calling mechanism based on binary encoding. Its core principle is that the combination of 8 discrete input signals, G4.0 to G4.7, generates a decimal number ranging from 0 to 255. This decimal number is then added to a predefined base number, for example, 100, to form the target program name. For example, when the input state of G4.0 to G4.7 is 0000101 binary, the system converts it into the decimal number 13. If the base number is set to 100, the program aimed to be loaded will be PNS 113. This design allows external devices, such as PLCs, to precisely control robot program scheduling using simple digital signals. To enable the PNS function, the user must enter main menu, I/O, PNS Enable, Settings interface to configure parameters. First, activate the PNS function switch. Second, set the base number, which determines the numeric prefix in program names. Third, set the feedback signal pulse width, which controls the output duration of the program load completion signal F5.0. During configuration, special attention must be paid to program naming conventions. The system strictly matches the format PNS plus number, for example, PNS 113. Leading zeros are prohibited. For example, PNS 013 is invalid. Additionally, in system settings, program selection menu, the load method must be set to PNS load and relevant safety checks. For example, program home position check should be enabled to ensure safe execution when programs are initiated. The PNS function uses a 3-layer signal interaction structure. 1. Input layer. G4.0 to G4.7 receive binary program numbers from external devices, for example, PLC output modules. G5.0 serves as the trigger signal. When set, the system locks the current G4.0 to G4.7 status and computes the decoded program number. G5.1 serves as the execution signal. When triggered, the system starts the loaded PNS program. 2. Processing layer. The system converts the binary input into a decimal number, combines it with the base number to generate the program name, and performs program load verification in the background. 3. Output layer. F4.0 to F4.7 mirror the real-time input status of G4.0 to G4.7, enabling external devices to verify signal accuracy. F5.0 outputs a program loading completion pulse, confirming that the program is ready for execution. The operator must initiate the PNS process in playback mode. First, press the Servo Ready button to enable the robot. Then, use an external device to sequentially trigger the G5.0 and G5.1 signals. Timing constraints. G5.0 must be triggered after the G4.0 to G4.7 signals have stabilized. Otherwise, decoding errors may occur. G5.1 must be triggered after the F5.0 signal is output. Otherwise, the program may start before being fully loaded. Additional notes. The PNS function does not support program scheduling. Only one program can be executed at a time. Signal triggering is valid only when the system is in a non-motion state. On an automotive welding line, the PLC can control signals G4.0 to G4.7 via digital output modules to dynamically schedule programs for different car models. For example, Model A, signal 00000001, load PNS 101, base number 100 plus decoded 1. Model B, signal 00000010, load PNS 102. This solution significantly simplifies the model changeover process on the production line. However, attention must be paid to signal debounce design. It is recommended to add a 50 millisecond delay filter in the PLC program to prevent signal fluctuations caused by mechanical vibration. When a program fails to start as expected, follow these steps for troubleshooting. Navigate to the I/O system signal interface to check signal status. Verify whether the actual input values of G4.0 to G4.7 match the target program number. Check whether F5.0 has output a pulse signal. If no pulse is detected, review the base number configuration. Program name verification. In the Program Management menu, ensure that the target program exists and that its name complies with the PNS Plus number format. Hardware diagnostics. Use a multimeter to check the signal voltage at the X2 port of the control cabinet. Input signals should be 24 volts plus or minus 10%. While PNS control is efficient, it has two key limitations. 1. The maximum number of programs is constrained by the 8-bit binary range, up to 256 programs. 2. It does not support multi-program queue scheduling. For scenarios requiring more complex scheduling, the RSR remote start request function is recommended. In environments with strong electrical interference, it is recommended to use shielded twisted pair cables for signal wiring and add a ferrite ring filter at the robot's grounding terminal to prevent false signal triggering. This lesson provided an in-depth analysis of the PNS control principle in industrial robots. Generate a program number via 8-bit binary signals, G4.0 to G4.7. Add the base number to form the target program name, for example, PNS 113, and strictly follow the PNS Plus number naming rule. Leading zeros are not allowed. By mastering the 3-layer signal interaction process, G5.0 stable trigger, F5.0 pulse, G5.1 start, and troubleshooting methods, You now possess the core capability to implement dynamic program, scheduling, and flexible production lines.